All right, here we are finally at some Algebra 1 type problems. On 61, the problems below require you to solve a system of equations. You can see what they look like right here. List three different methods, three of them, to complete that task and indicate how you know when to use each method. So let's focus on what the heck a system of equations actually is. And you can see examples of them on 62 through 65, right? So in general, what a system of equations is, you've got more than one equation with the same variable, okay? And so in general, however many variables you have, so you got x, you got y, you got two variables, that's how many equations that you need to solve that system. In Algebra 2, in a couple of years for you guys, you're going to up this a little bit. You're going to have three different variables, an x, a y, and a z, and then you'll need a third equation in order to solve those things. Okay, so let's begin by looking at some graphs, because that's usually what you do whenever you first start learning how to solve a system of equations. Oh, that's supposed to be an A. Equations. Yeah, there you go. Systems of equations. So just to repeat this, you've got more than one equation with the same variables. With the same variables. And the ones that you did last year mostly were linear equations with x's and y's. And then probably whenever you did quadratics, you maybe threw in a parabola up in there too. Okay, so let's say I'm just going to make up a set of equations here. Let's start with y is equal to a half x. Let's do this minus 5, let's say. So let's start here at -5 for the y-intercept. And then my slope here is a half, so I'm going to go up 1 and over 2, get a couple of points, and then go the other way, go down 1 left 2, get a couple of points there. And that should do it. And let's see how good of a job I can do of connecting these things. Like so. And I think I can grab this guy right here and make that look real pretty. Okay, so there you go. There's one equation. Now I need another equation. And just remember that whenever you have an equation, the graph here represents every single point that satisfies this equation. Now we only used ones that were convenient for us, the ones that were on grid marks, starting with the y-intercept. But anything in between here also is a solution to this equation. When we're talking about a system of equations, we have another equation that's going to satisfy that same set of requirements that, every single XY point satisfies that equation. But a system, you want to know what single point satisfies both of those equations. Okay, so I need another equation here, and I'm going to kind of work backwards in this case. I'm going to start with this point, and then let's see if I can get myself a pretty nice slope. Let's see. How about I do something like go up 1. Let's do, see, that's a 3. So I can go up 3 over 1, up 3 over 1, up 3 over 1, and up 3 over 1. Okay, so that should do it. And let me just put a nice nifty little line. Look at that. That's such a good line right there. Okay, that'll do it. And then snatch this part and then line that up a little bit better. Okay, there we go. And now, in case you're wondering, the equation that I just drew in here, this green one, is y is equal to, the slope that I just did was basically down 3 and right 1. So it's a -3. So a -3x, and its y-intercept looks like it's up here at +9. Okay, so I have a set of equations, two equations, and they have the same variables x and y. When you solve a system of equations, what you're trying to do is you're trying to find the point of intersection, right? A point of intersection is the point that satisfies both of these equations. So find point of intersection. Now, when we're talking about intersection, you've heard about intersection in terms of streets. Let's say that this right here is Teasley Lane, and this one here is Hickory Creek. I'm going to say that this is Kroger right over here, and you got McNair Elementary School. We got Geyer, that's right over here someplace. The intersection is right here at this green dot, and the intersection is on both of the streets. It's on both Hickory Creek and it's on Teasley Lane, and that's what we're looking for when we're solving a system of equations. And that's exactly why the first method that you usually talk about to solve a system of equations is called graphing, exactly what we just did here. So to solve a system of equations. Let me clean this up. I can't even read it myself. Equations, you've got number one method, graphing. And as I just said, what that just simply means is that you're trying to find the point of intersection. And our point of intersection, I just kind of work backwards in order to make this system of equations. And so we can see exactly what it is right here. It is the point 1, 2, 3, 4, 4, comma 1, 2, 3, negative 3. So this has the solution for negative 3. And of course, what that means is that this ordered pair satisfies the first equation and it satisfies the second equation. We can see that on the graph, but I'm going to put it in and I can also verify that that happens. So let's start with the red one. So my y here is negative 3 is equal to 1/2 times 4 and then minus 5. So the 1/2 times 4 is 2. Bring down this negative 3. So a 2 minus 5 and a 2 minus 5 is equal to negative 3, and you can see it checks out, right? And then if I plug it into the bottom one, the green one, again, my y coordinate is negative 3 is equal to a negative 3 times 4, and then plus 9. Okay, so negative 3 times 4 is a negative 12. Let me bring down this negative 3, and then plus 9. So negative 3 plus 9 gives us our negative 3. Equals negative 3. Checks out, right? All right, so that's essentially what it means to be the solution to a system of equations. And the first way to find that, of course, is through graphing.